Okay students, in the last class we have discussed about what actually the chemistry is and how actually chemistry play a very important role to lead the life. So, chemistry is mother of all the subjects, we can say. It is because without chemistry there is no explanation of nature. And one more thing, that is chemistry is very much useful to lead the physical and physiological life. That means if we want to lead the life physically as well as physiologically, chemistry is must. Without the knowledge of chemistry, it is very difficult to understand what actually the nature is. So, after that, in the last class, we knew about what actually chemistry and then development of chemistry, then importance of chemistry. Now, we will concentrate on the next part of the topic called what is matter, types of matter and other important concepts. Okay. Now, nature of matter. We know that matter is anything which has a definite mass and occupies a definite space is called as matter. So, anything which may be visible or invisible, but if it occupies a space and having a definite mass, such a substance or such things we call it as matter. Example, you can take book, pen, pencil, water, air, elements, compounds, anything. Anything if it occupies a space and having a definite mass is considered as matter. Then, states of matter. Actually, when we look at the matter point of view, classification play a very important role. Actually, when you look at the classification of matter, it is broadly divided into physical classification and chemical classification. Physical classification, that means purely the external appearance of the matter. On the basis of external appearance, we can classify the matter into the physical classification. Based on its chemical nature, chemical properties you can say, chemical activities you can say, it is classified as chemical classification. In physical classification, you will find again three types. One is solid, another one is liquid, third one is gas. Like that, if you go with the chemical classification, there you will find pure substances and mixtures. Pure substances are further classified into, concentrate the classification, pure substances are further classified into elements and compounds, whereas mixtures are further classified into homogeneous as well as heterogeneous mixtures. Further, elements are subdivided into metals, non-metals and metalloids. So, elements are further divided into metals, non-metals and metalloids, whereas compounds are classified into two types. One inorganic compounds, another one is organic compounds. So, this is the broader way of classification of matter. I will repeat, matter can be classified into two broad categories, two broad classifications. One, physical classification, which is purely based on the physical appearance of the matter. Based on that, you will have three important subcategories. One, solids, liquids and gas. And another one is the chemical classification. There you will find two. One is pure substances and another one is mixtures. So here pure substances are further classified into two types again. One is element and another one is compounds. And these elements are further classified into metals, non-metals and metalloids. Whereas the compounds are classified into two types: inorganic compounds, organic compounds. Further, the mixtures are classified into two main classes. One we call it as heterogeneous mixtures, another one is homogeneous mixture. Now we will see in detail about each and every part of the classification. Okay, so first we will concentrate on physical classification. Now there are three types, as you know already. One is solid, another one is liquid and the third one is gas. Actually, based on this is purely a physical classification based on appearance. Here if you go with the solids, solids are highly rigid. They have a fixed shape and a fixed volume. They have fixed shape and they have fixed volume. This is only because of the compact arrangement of atoms or constituent particles. If the constituent particles, whether it may be atom or molecules, when they are closely packed, when they are closely arranged, there you will get a definite shape and a definite volume. And because of this closed compact arrangement, they develops rigidity. Okay, so that is about the solids. And if you go with the liquids, so here liquids are not rigid actually, and they do not have fixed shape. They do not have a fixed shape, but they have fixed volume. What is the reason? Here the molecules are little bit far away from one another. In liquids, the constituent particles are little bit far away from one another. Hence, they develops a volume, but they do not develops a definite shape. So that is the characteristic properties. You can say liquids, they are not rigid, they are having no fixed shape and they have fixed volume. That is about the liquid. And gas, if you go with the gas, here the molecules are far away from one another. They are totally far away from one another. Therefore, neither they have a definite shape nor they have a definite volume. Neither they have a definite shape nor they do not have a definite volume. It is only because here the molecules are very much far away from one another. Here they simply occupies the volume of the container. They simply occupies the volume of the container. So this is about the solid, liquid and gas. Another point, in broader sense, a solid is one whose melting and boiling points are above the room temperature. Solid is one, when we call it as a solid, if that substance has melting as well as a boiling point above the room temperature. This is general view, I can say. In case of liquids, their melting temperature is below the room temperature, but their boiling point is above the room temperature. But in case of gases, both melting and boiling points are below the room temperature. This is what we can say when we call it as a solid or liquid or gas. Then what is the difference between gas and vapors? That question arises. So here a small difference is there between the gas and the vapors. If the substance exists liquid at room temperature and when it is heated and enters into the gaseous state, then instead of gas we can say it as vapors of that substance. If the substance already exists in the gaseous at room temperature, then it is called as gas. So, small difference is there, gas and the vapors. We call it as vapors only when that substance exists in the form of liquid at room temperature. So, this is about the physical classification of matter. Okay. In detail again about solid, liquid and gas we will see in the next topics. States of matter is there, and in the second year a separate bit was there called solids. At that time you will come to know the complete characteristic properties of solids, liquids and gases. Okay. Now we will switch on to the next one. Yes, one more important point here. As such matter, that is solid, liquid or gas, they are interconvertible. That means solid can be converted into liquid, liquid can be converted into gas only by either changing the temperature or pressure. That means as such there is no demarcation between the three states, solid, liquid and gases. So, solid can be converted into liquid, liquid can be converted into gas, gas can be converted into liquid, liquid can be converted into solid only by changing the conditions of temperature and pressure. So, that means here they are interconvertible components. This is about the physical classification of matter. And one thing, for example, if you take water, ice below room temperature, it is solid in nature. Room temperature and above room temperature, it is, or you can say below 0 degree Celsius. Below 0 degree Celsius, water exists in the ice state, solid state. But when it is entered into the room temperature, then or above 0 degree Celsius, you can say it is in the liquid state. But when it enters into the 100 degree Celsius, it exists in the form of vapors or gaseous state. Again, when vapors of water are cooled, it becomes liquid droplets. And when these liquid droplets are placed in the refrigerators, you will get the solid ice again. That means here they are purely interconvertible. Only the means changing the pressure and the temperature. Next, here interconvertible part. When solid directly enters into the gaseous state, that phenomena we call it as a sublimation. One such example is iodine, camphor. Iodine and camphor and naphthalene, ಡಾಂಬರ್ಗೋಳಿ ಅಂತ ಹೇಳಿ ನಾವು ಹೇಳ್ತೀವಲ್ಲ. So these are directly entering from solid state to gaseous state. Such phenomena is called as sublimation. If a solid is converted into liquid state, that we call it as a melting. Definition of melting, that means we can say melting. If liquid is converted into solid, then we call it as a freezing. Okay, like that liquid to gas is called as vaporization, and gas to again liquid, condensation. So this is what we call it as interconversion factors. So solid to liquid is nothing but melting, liquid to solid is called as freezing, liquid to gas vaporization, gas to liquid condensation. So gas to solid is nothing but reverse sublimation. So this is about the next slide. Now, so this is already explained to you. Now we will see about chemical classification of matter. Broadly speaking, there are two types. One we call it as pure substances, and another one we call it as mixtures. So, pure substances by means of physical separation, by means of physical separation. Here the point is mixtures can be separated into pure substances by means of physical separation. Okay, that is one point before going to the classification. Now we will concentrate on the classification point of view. So here there are two major types, one is pure substances and another one is mixtures. Pure substances are broadly classified into, as you know already, two types: elements, for example oxygen, hydrogen, iron, copper, like that. Then compounds point of view, you can take water, table salt, that is sodium chloride, ammonia you can take, calcium carbonate you can take, any kind of examples you can see. Whereas mixtures are further classified into homogeneous mixtures and heterogeneous mixtures. In homogeneous mixtures, the examples are salt dissolved in the water, air you can say, that is homogeneous mixture, and you can take alloys, you can take the alloys as an example for homogeneous. Heterogeneous, sand mixed with sugar, or you can say this milk in the water or water in the milk, that forms heterogeneous mixture. So that is about the examples of homogeneous and heterogeneous. Now we will see in detail about what actually the pure substance and what about the mixtures. Okay. Yes, pure substances. Constituent particles of pure substance have a fixed composition. Constituent particles of pure substance have a fixed composition. That means they are made with only one kind of either atoms or molecules. They are made up of only one kind of atoms or molecules, and here particularly if you take the molecules, there they maintains a definite and fixed composition. For example, you can take the example of copper, which is made up of copper atoms, silver, gold, water. In water you will find two hydrogen atoms with one oxygen atom. It is a fixed always. Whenever you take water, there you will get two hydrogen atoms and one oxygen atom. Like that glucose. In glucose you will find C6H12O6. C6H12O6. That means there you will find the fixed composition. 6 carbon atoms, 12 hydrogens, and again 6 oxygen atoms. C6H12O6. 6 oxygen, 12 hydrogen, 6 carbon. That means there you will find a fixed composition and fixed ratio of atoms, particularly if you go with the pure substances or compounds. Okay. Now, yes, pure substances can further classified into two. One is elements and another one is compounds. Now this concentrate. Particles of an element consists of only one type of atoms. These particles either may exist in the form of atoms or in the form of molecules. One example, just I will quote here. You can take example of sodium. Sodium exists as sodium atoms. Whereas if you take hydrogen, it exists in the form of molecule, that is H2. Whenever we want to write the hydrogen, we are writing H2 because of its stability. That means it always exists in the form of molecule. So generally Some elements occurs in the form of atoms and some elements may occur in the form of molecules. Chlorine you can take, it is a molecule, Cl2. Ozone you can take, that is O3 actually, it is a triatomic. If you take sulfur, S8 it was, octaatomic component it is. Like that, because of their stability, because of their existing, because of their capacity to get the stability, they will combine with another same kind of atom to form the molecules. Now here you can see the picture. There you will get the atoms: hydrogen, oxygen, nitrogen, copper and sodium. These are atoms of different elements. Particularly hydrogen exists in the form of H2, oxygen exists in the form of O2. That means here one atom of oxygen combined with another atom of oxygen to form oxygen molecule. Okay, so like that, there are some elements which occurs in the form of simply atoms, and there are some elements which occurs in the form of molecules, maybe diatomic, triatomic, tetraatomic or polyatomic states. Okay. Now we will concentrate on compounds. When two or more atoms of different elements, when two or more atoms of different elements combine together with a definite ratio, then compound is obtained, compound is formed. Then what is actually a compound? It is a product, formed when two or more atoms of different elements combined together in a fixed ratio. That is very, very important, definite ratio. That is the main difference between the compound and the mixture, because in case of mixture there is no definite ratio, but in compounds, whenever the two atoms are combined, and they combined chemically, not physically, they combine chemically. So here they combined chemically with a definite ratio, then that product we call it as compound. So what is actually compound? When two or more atoms of different elements combine together chemically in a definite ratio, the compound is going to be formed, and the smallest particle of compound is called as molecule, Now actually these compound, that the constituent particles of the compound cannot be separated into simpler substances by physical means or physical methods. One example I will quote here. Water is formed from hydrogen and oxygen. Water is formed from hydrogen and oxygen. Once hydrogen and oxygen combined to form the water, and from that water you cannot easily separate, hydrogen and oxygen by means of physical methods. Physical methods means by separation, by filtration, by sublimation. All these physical methods cannot be used to separate the constituent particles of a compound, but they can be separated by means of chemical methods. For example, when water is electrolyzed by adding a small amount of acid, because water is a bad conductor. So if we add small amount of acid, that increases the conductivity of water. So therefore, when water is electrolyzed, then hydrogen and oxygen were formed. That method we call it as chemical method, not the physical method. So that is the another difference you can notice between the mixture and the compounds. Mixture can be separated by means of physical methods, but compound cannot be. Compound constituent particles cannot be separated by means of physical methods. So that is another important note. Student, here first time you just listen the concept, second time you see the video 2 times, so that first time you just listen the concept and try to understand. Next time you just note down the points which are displayed on the screen. That is very important, because these are the selective components, so that you can make the note for that. So preparation of note is also going on simultaneously. So that is about the another point. Okay, now examples of some compounds. You can take carbon dioxide, which is formed from carbon and oxygen. Water, you can take H2 plus O2, that is H2O, water. Ammonia, N2 plus H2 give rise to NH3, ammonia. Like that, there are several examples are there for the compounds. So here 2 hydrogen atoms are combined with 1 oxygen atom, and 2 oxygen atoms are combined with 1 carbon atom to give carbon dioxide and water molecule. Okay. Second, the atoms of different elements are present in a compound is a fixed and definite ratio, as I already told, and this is the characteristic property of a particular compound. For example, if you take C plus O2 give rise to CO2. Here the ratio will be 1:1. Carbon is also 1, oxygen is also 1. And in case of water, H2 plus O2, if you give it gives H2O. To balance this, 2H2 plus O2 give rise to 2H2O. 2H2 means the ratio will be 2:1. So that means in every compound, even though the same elements are present, but they are present in a definite and different ratios. They are not in the same ratios in all the compounds. It varies from compound to compound. Okay. Another important point. If I take the example of water, which is made from hydrogen and oxygen. So here hydrogen is combustible material, oxygen is non-combustible material, oxygen is supporter of combustion, whereas water is used as fire extinguisher. That means here the point is the formed compound will never exhibit the characteristic properties of its constituent particles. Hydrogen is a combustible, oxygen is a supporter of combustion, water is used to fire extinguisher, and moreover hydrogen and oxygen are gases, whereas water is a liquid. That means both physically as well as chemically, the compounds are totally different from that of their constituent particles. So that is about the very important and interesting point, because what we are expecting, when they are made from 2 elements, definitely they will show the same characteristic properties which are related to their constituent particles, but in fact they do not have that properties. They totally shows different properties. Okay. Next, yes, already that was explained to you, that is hydrogen burns with a pop sound and oxygen is a supporter of combustion, but water is a fire extinguisher. Next comes after this pure substances, mixture. A mixture contains particles of 2 or more pure substances which may be present in it in any ratio. That means what is actually a mixture is? Mixture is nothing but a kind of substance in which we are mixing, we are adding different pure substances with any kind of ratios, That means one such example I can take alloys. You can take the stainless steel. In stainless steel we find iron, carbon, manganese, nickel and chromium. So here chromium, iron, carbon, these are present in different ratios. They do not have any fixed ratio. So that is what we call it as mixture. ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು ಹೇಳಬೇಕಂದ್ರೆ, ಇಲ್ಲಿ ಮುಖ್ಯವಾಗಿ ನೀವು ಈ ಒಂದು ಸ್ವೀಟ್ ಸ್ಟಾಲಿಗೆ ಹೋದಾಗ ಮಿಕ್ಸ್ಚರ್ ಕೊಡ್ರಿ ಅಂತ ಹೇಳಿದಾಗ ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ, ಅಲ್ಲಿ ಅವ್ರ ಎದುರುಗಡೆ ಇರುವಂತಹ ಆ ಒಂದು ಖಾರದ ಐಟಮ್ಸ್ಗಳಲ್ಲಿ ತಮ್ಮ ಕೈಗೆ ಎಷ್ಟು ಅನುಕೂಲ ಆಗುತ್ತೆ ಅಷ್ಟೆಲ್ಲ ಹಾಕಿ ಒಂದು ಮಿಕ್ಸ್ಚರನ್ನು ರೆಡಿ ಮಾಡಿಕೊಡ್ತಾರೆ ನಿಮಗೆ. ಅವ್ರು ಇದನ್ನು ಇಷ್ಟೇ ಗ್ರಾಮ್ ಹಾಕಬೇಕು, ಇದು ಇಷ್ಟೇ ಗ್ರಾಮ್ ಹಾಕಬೇಕಂತೇಳಿ ಮಾಡೋದಿಲ್ಲ ನೋಡ್ರಿ. ಯಾವುದು ಎಷ್ಟು ಕೈಗೆ ಸಿಗ್ತದೆ ಅದಷ್ಟನ್ನು ಹಾಕ್ತಾ ಹೋಗ್ತಾರೆ. ಆವಾಗ ನಮಗೆ ಟೋಟಲ್ ಒಂದು ಮಿಕ್ಸ್ಚರ್ ಅಂತೇಳಿ ಸಿಗುತ್ತೆ, ಖಾರ ಅಂತೇಳಿ ಸಿಗುತ್ತೆ. ಅದೇ ಒಂದು ಎಕ್ಸಾಂಪಲ್. ಅಂದರೆ ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಒಂದು ಡೆಫಿನೇಟ್ ರೇಷೋನಲ್ಲಿ ಹಾಕೋದಿಲ್ಲ. ಅದೇ ಮಿಕ್ಸ್ಚರ್. ಪ್ಯೂರ್ ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳನ್ನೇ ಹಾಕ್ತೀವಿ. ಈ ಪ್ಯೂರ್ ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳನ್ನು ಹಾಕಿದಾಗ ಅಲ್ಲಿ ಯಾವುದೇ ರೀತಿಯಿಂದ ರೇಷೋ ಮೇಂಟೈನ್ ಆಗೋದಿಲ್ಲ. ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಮಿಕ್ಸ್ಚರ್. ಸೊ ಇಟ್ ಈಸ್ ಕಂಟೈನಿಂಗ್ the particles of two or more pure substances which may be present in any kind of ratios. Again there are two types, as you know already. In a homogeneous mixture, there you will get the components which are mixed in that are having uniform throughout. That means here the components are uniformly distributed throughout the bulk of the mixture. That means here you cannot differentiate the two components. For example, salt solution you can take. Here salt is also there, water is also there, but when you look at that salt solution, you will get only one kind of solution. When you taste it, then only will come to know, oh, it is salt solution. Like that sugar solution. That means in case of homogeneous mixtures, the components which are present in that are uniformly distributed. One point I would like to tell here, when the mixture becomes homogeneous, that question arises. When the mixture becomes homogeneous, it becomes homogeneous only when the density of the different components and the pressure of the different components, that is pure substances, are same. If two components are having same density and same pressure, exerting same kind of pressure, then it develops a homogeneous mixture. So that is about the homogeneous mixture. Okay. Next examples, as you know already, sugar solution, salt solution, air are the common examples of homogeneous mixtures. In heterogeneous mixture, the composition is not uniform throughout. You can take the example of water in oil or oil in water. There you will get physically what? Differentiating components. That means here in this kind of mixture the composition is not uniform throughout. That means the different components or the different pure substances which were added to that are clearly appearing, clearly visible. For example, you can take mixture of salt and sugar, grains and pulses, and you can take oil in water. These are nothing but what? Heterogeneous mixture. What is the cause for the heterogeneous mixture? Here the density and density and pressure exerting by the components will be totally different from one another. So that is about what? Heterogeneous mixture. So in the next class we will see about the next part of the topic. Okay, thank you.